Hey there everyone. Today we are going to start performing some different operations on radicals. We are going to focus on addition, subtraction, and multiplication in this video, and then later on we'll get to the division. Okay? So let's start with addition and subtraction. You are only able to add and subtract what are referred to as like radicals. Like radicals are radicals that have the same index and the same radicand. It's a lot like the idea of like terms. Like terms are terms who have the same variable with the same power. So same kind of idea here. I have some examples here of like radicals on the left side of your screen. 3 times the fourth root of 2 is a like radical with -4 times the fourth root of 2. That's because they both have the same index of 4. They're both fourth roots, and they both have the same radicand of 2. Okay? Now, I also have an example of unlike radicals. 2 times the fourth root of 3 and the cube root of 3. Notice that both of those radicals, they have the same radicand, but their index in each are different. So those would not be able to be added or subtracted from one another. All right, so let's get into this example. Would like to simplify this as much as possible. That includes combining any like radicals and making sure any radicals in my final answer are completely simplified. Okay, so notice as of right now, none of these radicals have the same radicand, but they can all be simplified slightly. So let's do some factor trees here. 8 is, of course, 2 and 4. 4 is 2 and 2. 32, we'll do 16 and 2. 4 and 4. 2, 2, 2, 2. And then 54, how about we do 9 and 6. 3, 3, 3, 2. Okay, so now I'm gonna rewrite this with each of the radicals in their factorizations. So this would be 3 times the square root of 2 times 2 times 2 plus 5 times the square root 2 times 2 times 2 times 2 times 2 minus 4 times the cube root 3 times 3 times 3 times 2. Okay, and then we're looking to see what we can pull out of each of these radicals based on the index. So the radical that's furthest to the left here, it's a square root, so I'm looking for pairs of the same number. That means I'm able to pull a 2 out. Let's think of this as 3 times 2 radical 2. In the middle radical, I've got a pair of 2's and then a second pair of 2's. So I'm going to be able to take that 5 that's already out in front, and I can multiply it by a 2 and then by another 2 before multiplying by the square root of 2. Okay, and then the last radical, notice the index is 3. So I need 3 of the same number, which I have right here. I can pull a 3 out now and say 4 is being multiplied by 3 times the cube root of 2. Okay, now let's clean this all up a little bit. 3 times 2 radical 2 would be 6 radical 2 plus 5 times 2 times 2 radical 2, that would be a 20 radical 2, and then minus 12 cube root of 2. Now notice all 3 of those radicals, they now have a radicand of 2. However, these are the only 2 radicals that are like radicals because they're both square roots. So I'm able to combine these together, and when I combine them, I only add the numbers that are in front of the radical. I don't do anything with the 2 that's underneath the radical. So this is going to become 26 times the square root of 2 and then just carry down the subtraction by 12 cube root of 2. And this would be as simplified as that expression will get. Okay? All right, now on to multiplying. You are able to multiply two radicals together as long as they have the same index. Okay, they have to have the same index. Radicands can be different. All right, so that's a little bit different than addition and subtraction. All right, so first example here, I'm trying to take 4 times the square root of 24 and multiply that by 3 times the square root of 20. Okay, so first understand that anything that's outside the radicals here would get multiplied together. So I'm going to take 4 and 3, multiply those together, and then anything that's underneath the radicals will get multiplied together. Okay. Now, I'm not actually, I'll multiply the 4 and the 3 here. I'll make that a 12. But then the 24 and the 20, I'm not going to multiply those. I'm just going to look at their factorizations. Okay, so 24 is 4 and 6. 4 is 2 and 2. 6 is 2 and 3. And then 20 is 4 and 5. 4 is 2 and 2. Okay, so let's reorder things here. Put all the 2's next to one another, then the 3, then the 5. All right, so now I'm looking to see if I can pull anything out based on the index. This is a square root, so I'm looking for pairs of the same number. There's a pair of 2's. There's another pair of 2's. And that means I'm able to pull a 2 and a second 2 out. So 12 is already out in front. I'm going to multiply that by a 2, another 2, and then inside you're left with the 2 times the 3 times the 5. Okay, now we clean it up. 12 times 2 is 24. 24 times 2, 48. And then 2 times 3 is 6. 6 times 5 is 30. That is your simplified answer. Okay. All right, next one, I'm going to simplify the radicals, or I'm going to factor the radicands of each of these radicals first, and then we'll think about multiplying them together. Okay, so let's treat the first here. This is, keep that 5 out in front, and then 24x cubed. That would be the same as 2 times 2 times 2 times 3, and then of course x, x, and x, right? And I want you to notice that the index on that radical is 4, and once you have the factorization here, see there's nothing that is repeated 4 times. So that radical in itself doesn't simplify. Okay, now let's do the same thing with the next radical expression. I have the 4, and then 4th root. So 54 is 6 and 9. 6 is, of course, 2 and 3. 9 is 3 and 3. So this would be 2 times 3 times 3 times 3 times x. Now, once again, notice there is not 4 of the same factor in that radicand. Okay? If we multiply these two radicals together, the 5 and the 4 that are on the outside, they'll multiply each other. And then these factorizations can just combine with each other. Okay? So now I'm going to have a total of 4 2's as well as a total of 4 3's as well as a total of 4 x's. Okay? So that means I'm going to be able to pull a 2, a 3, and an x out. And there will be nothing left inside this radical. The radical completely clears here. and multiply those all together. 5 times 4 is, of course, 20. 20 times 2, 40. 40 times 3, 120x. And there is no need for absolute value on that x now that it's outside the radical, because none of my powers on x were even to begin with. So this is my simplified answer. Okay. All right, at this point, it is your turn. You are going to move to practice 1. You're going to work through those problems yourself. And then when you're done, come back to the video and check your work.